is that today obligations are specified in English in the real world. They're Word documents. And we really don't have any effective language in which to express them. So semantically, we have deontic logics that we can use to express obligations at a very abstract philosophical level. We have linear temporal logic. That's the example I gave you. But it's way too powerful. It's more powerful than what we really need. And we have operational representations of obligations which are really pairs of actions and time intervals. And none of these is really satisfactory. The action time interval doesn't allow us to express a lot of the examples I mentioned earlier. LTL is too powerful to express them. So what we really need is a representation that's somewhere in between these two. Analysis. Given an obligation we would like to be able to answer, is an obligation satisfiable? Does one obligation imply another? If I am obligated for one thing, is it okay for me to assume another obligation? Or is it redundant? Are there conflicts between obligations? If I am trying to share data with somebody, I require certain obligations to be satisfied. They have some notion of obligations. Can we find a match? Enforcing of obligations is probably, in fact, probably the hardest problem. That what we need is techniques that would allow us to manage obligations, keep track of them, represent them, allow us to know exactly what our obligations are. And then we need techniques to audit and monitor for compliance of these obligations. Now, this is actually a very hard problem because when you give data, the data is on the other person's computer, and yet you want to know that certain policies are being satisfied on them. This is a classic challenge that DRM faces, except over here we're talking about a different class of problems, or of policies. And if somebody does violate the obligations, we need to have penalties, notifications, exceptions, a lot of mechanisms to deal with those eventualities. There are a lot of extensions that are still needed in terms of existing frameworks. The first is that obligations occur in the context of certain organizations and tasks, and we need ways of representing them. And the second is that when data is derived, how do we figure out what are the obligations over derived data? And finally, there's administration. That how do we really organize obligations? How do we manage them? We know how to manage privileges. We have role-based access control to do that. How do we manage obligations? We know how to do negotiation. We have trust negotiation to do that with privileges. How do we do negotiation with obligations? There are a lot of open problems in this area. And in summary, what I'd like to effectively say is that the problem of dealing with policies in this new world of the internet requires a new set of mechanisms. We need to be able to express data channels between principals. That's fairly simple. We need to be able to manage risk-benefit trade-offs in the context of specific missions. So, for instance, we want to share a patient's medical record with a nurse only if she is treating the patient. We would like to have the ability to specify alternate actions when a particular sharing action is going to be rejected. So if Bob requests an object and is denied, then we would like to be able to send the object to somebody else. And obligations. We would like to have the ability to satisfy constraints that parties are obligated to satisfy in the future. So for instance, if Alice receives an object from CDC, she must notify CDC if someone else gets the object. Now, I've given some indications of some approaches to these problems. If you have further questions, I'd be happy to discuss any of these approaches in more detail, or we can discuss this afterwards. So I'm going to end here and actually take questions if there are any questions.
Well, on your, I guess, slide 35 and the challenges. Yes. The linear temporal logic. Can you elaborate on that, please?
Okay, sure. So linear temporal logic is really allows you to express constraints on sequences of actions. So the idea over here is that if you have a sequence of actions, which are, let's say, sequences of message sends, receives, store updates, and the predicates that you have are actually up here. So oh, this doesn't work. Okay. A question of really parsing or specifying. It's a question of being able to analyze obligation specifications. That LTL certainly lets us express everything we would like to express, but we could probably do with a lot less and be able to have much more, be able to, so for instance, some of the properties I would like to be able to answer are, is an obligation satisfiable? Does an obligation subsume another? Now, these kinds of things you can do with LTL if you use model checkers, but in practice, we really shouldn't be using model checkers for access control. That if you had a simpler language and you were trying to, so the question is, why do we need to do this at runtime? And that really comes to the third problem. Let's say you have a pub sub environment, and the publisher posts some data with a particular obligation, and the consumer wants to subscribe to this data. That really requires you to match up these obligations, and that in turn requires the first two problems to be solved at runtime. So my point really is that what we need is a simpler version of LTL that's more efficient and that lets us answer these kinds of questions.
But how do we assume that the whole thing is linear anyway? How do we know that it's linear?
We don't necessarily accept that all of the examples that we've looked at we can express using LTL. And we've actually taken a large number of sharing agreements that were expressed in English in the real world among organizations, and we've been able to express every one of those policies that involve obligations using this language. And there's been some related work out of Stanford where they looked at privacy legislation, and privacy is very related to obligations, and they found that they could express every one of those policies using LTL.
You're referring to Michel's group?
That's right, Michel's work. So the language appears powerful enough to express most real-world policies that people express.
I mean, one of the things, and one of the arguments I think for your simplicity, I mean, it's not just real time, but it's also, I mean, this Bob agrees to obligations B. Can we find a match? Well,